I bring an idea for you today. As you may already know, with a good understanding of the problem to solve, even a simple architectural pattern is enough. And on the other hand, with a poor understanding, there is no amount of clean code, clean architecture, hexagonal, DDD, event-driven, ChatGPT, Copilot, that is going to make your application easy to maintain and easy to evolve, because the most important factor when building software is not code, is the understanding. Hi, my name is Ivan Garcia. I'm a Java architect at Singular, and I help teams and organizations create software easy to understand at scale, because I believe that being easy to understand should be the gold standard for good and maintainable software. And in this session, I'm going to share with you some tools and techniques to compress the feedback loop between expert knowledge and working software, to shorten the time from domain exploring to a working solution. And because I believe that working software is worth more than 1,000 words, this session is going to be a practical one. We are going to do some live coding. We are going to deconstruct and build back together an event-driven application composed by 4 microservices based on your domain model and of your domain understanding. So if you like the idea, stay with me and let's do this. Okay, these are some of the tools and concepts that we are going to use during this session: domain-driven design, event storming, event-driven architectures, and ZenWave 360. And domain-driven design, which is already 20 years old, wow, still more relevant than ever, proposes to use language as the key tool for creating a shared understanding of the problem space and the solution space. And this model should be a good foundation to accommodate change in the direction of business experts' perspective. It distinguishes between the problem space and the solution space. The problem space always comes first. The problem space is your client's problems. Your client's problems is the problem that you are trying to solve. This is to be recognized and understood. And it focuses on who, what, and why. And the solution space that always comes later is your business. Your business is the solution. This is about how you are going to build a value proposition to solve your client problems, and always come after understanding the problem space. It comes with some strategic tools, mostly about understanding which domains are supporting or generic, but at least one of these domains should be a core subdomain. The domain where your business is trying to build a differentiating value proposition to solve your client's problems. And it comes also with a lot of tactical tools that are already part of the industry standards for process modeling and for designing your software. And event storming is a collaborative workshop we can use to explore the problem space and to design a solution. It comes in different sizes and different shapes. Big picture event storming to explore the problem space and to design, to model a process for your solution. And also a small picture event storming that we can use to design our software from commands, preconditions, to outcomes or event or domain events. And we can use it to design our software from commands to aggregates to domain events. And thanks to ZenWave, domain-specific language, we can map the discoveries of these event storming sessions into a developer-friendly language and machine-friendly language that we can convert later on into different software artifacts, retaining the language of your business, retaining the understanding that we build during the event storming sessions. And event-driven architectures, the go-to pattern for building modern applications. Why? Well, because it makes sense, because that's how we conduct business and how we conduct ourselves in real life. We react from different messages, and as a result, we produce new messages for the next one. So it makes sense to model our software as we conduct our business in real life. And it comes with some advantages at runtime, mostly about scalability and loosely coupling, but it comes also with very important to scale our teams, because it reduces the cognitive load of our teams, because each team doesn't need to understand and doesn't need to know about the implementation details of other domains. It's just about interchanging messages on a conversation where you just need to know where to send the next message and when to listen for the messages that you are interested. And ZenWave 360, which is a set of tools for modeling tools for applying DDD and API-first patterns for event-driven applications. And it can help compress the feedback loop between expert knowledge and working software, thanks to a domain-specific language that it looks like this. This is an example that can map the results of our understanding that we build during the event storming sessions. It's a language which is developer friendly. It's very easy to get if you are a developer, but it retains the language of your business that you discovered during the event storming sessions. Because it's machine friendly, we can use it to generate different software artifacts that we can assemble together to build applications in no time. If we are dealing with a supporting or generic domain, when we understand the problem to solve, the solution emerges with this tool, we can help you provide value for your business and your customers much faster. But if we are dealing with a core domain where the solution is unknown beforehand, it's a matter of creating a differentiating value proposition where we need to iterate different hypotheses. ZenWave can help us avoid the sunk cost fallacy. Sometimes when we invest too much effort and time and money in one solution, sometimes we get trapped by it. Thanks to ZenWave, you don't need to get married to your first idea that might not be the best one yet. You can validate different hypotheses and cut your losses. And as I said before, because I believe that working software is worth more than 1,000 words, in this session we are going to deconstruct and build back together an event-driven application, an online food delivery service that is composed by 4 different bounded contexts or microservices, depending on how you deploy them. This is kind of a simplification. It's not going to be the next killer app, but it has complexity enough to showcase these event-driven concepts and model a complex domain. So let's go to code. Okay. First of all, I would like to show you what this application is about. All the source code is available. You can find it in GitHub. We will place one link in the comments. Here is the source code. And as I said before, it's composed by 4 microservices. In this demo, we are going to deploy them as a modular monolith because it's easier for me to deploy them all together, but they are actual microservices. They share nothing. Each of them has an API first specification for asynchronous messages and an OpenAPI specification as well for synchronous communication. And they work as loosely coupled components, event-driven. This is a choreography, and it implements an implicit saga. So when a customer places a new order, the orders module requests from the customer's module some data synchronously, but all the rest of the communication goes through a broker. We are going to use Kafka in this example. So the orders module places the order details on this channel, so the restaurants and delivery can subscribe to it, and they feed back their status changes to this other channel, so they work as a choreography. But even if it's a choreography, the orders module works kind of a master of ceremony, because restaurants and delivery, they don't talk to each other. They talk by the orders module. And this is the happy path for the order status. When an order is received and the kitchen and the delivery accept the order becomes confirmed, and then the kitchen can start in progress, and it goes by different status. And this is the happy path. Any module can cancel the order at any time. So it's an implicit saga. And of course, each of these bounded contexts has a domain model inside. And as I said before, this is event-driven. They share nothing. All the communication goes through AsyncAPI and OpenAPI. And we also have here ZenWave ZDL blueprints, or the domain-specific language that models these microservices. So what I want to show you now is this application working. So here I have the application. I have a module, one of different modules. They share nothing. All the communication goes by APIs. And I'm going to start some Docker containers for MongoDB and for Kafka. So when we have them running, I have here a small script that is going to connect to Kafka, subscribe to all these topics, and print the different messages in different colors, so we can debug what is happening behind the scenes. So let me bring this back. Okay, we are subscribed to all these topics. So I want to show you how this works, so later we can deconstruct it and build together again module by module. So I'm going to start the application. And after it starts, I have here an HTTP script that I'm going to use first to create one customer with these details. Okay, so this is the HTTP response that we got from the REST API, and this here is the message that the customer's module sent to the customer event topics. We can create also one restaurant. Again, this is the HTTP response. This is the message that we got in the Kafka topic. And now I'm going to copy this customer ID, because we are going to create one order for this customer. at this restaurant to be sent to this address with these order items. Okay, so when I create the order, the response that we get is that the order was received, but a lot of interesting things happen behind the scenes. First, the orders send a message that it has received a new order, and restaurants reply that it has accepted the order. Delivery also send a messages explaining accepting the order, and when both are accepted, the orders set the status to confirm, so the restaurant can start in progress, and the orders module feeds back that the kitchen is in progress. So we can use, for instance, this kitchen order to drive the workflow a little further. We can set this kitchen order to ready, and we see that once the kitchen order is ready, the delivery is in progress, and the orders module broadcasts that this is on delivery already. And okay, this is a simplification. It's not going to be the next killer app for food delivery, but it has complexity enough to showcase an event-driven application. Anyone can cancel this order at any time, regardless of the implications that in real life may have. So if I get this customer order ID, I could send a message to the orders module to cancel the order, and delivery and restaurants also cancel the order. Okay, so this is the application working. What I would like to do now with you is to deconstruct this application and build it back. So first thing, I'm going to stop the application, and we are going to build it back, of course, from these blueprints, this ZenWave domain-specific language. We have one blueprint for each application, but before I show you what is inside these blueprints, let's visit ZenWave 360 webpage, which, as I said before, is a set of modeling tools for applying DDD and API-first practices for event-driven applications, and it comes with a domain language, with a toolkit that helps you convert this language into different software artifacts for event-driven architectures, API first, and API testing. And if we go inside the documentation, well, there is information about what ZenWave is. You have information to get started, install the command line, install the IntelliJ model editor. You have information about doing domain modeling. There is a lot of information about doing event storming that we can use to explore the problem space, but also to design our software, from commands to aggregates to domain events. And there is here a section for the domain language about how you can use this language to map the findings of these event storming sessions. You have information about the file structure, creating entities and aggregates, creating services, domain events, API. You have here all the information, but before we get into building a backend application with this structure, I want to show you here in the SDK link at the top, we have the list of all the available plugins that are already available with ZenWave. You can create your own custom plugins, and they let you work with OpenAPI, with AsyncAPI, and build a backend application. You have here, for instance, how to convert a ZDL model into an OpenAPI specification definition with these options, or into an async API definition with these other options, a full backend application, and it comes with a complete toolkit for doing API first with Async API version 2 and version 3. Okay, so the picture that I want to show you now is this one, that maybe is better. Okay, so this model, this domain modeling language is for describing the inside of a clean architecture. We are going to use for communicating to different bounded contexts or to different microservices very well-known API first specifications like OpenAPI and AsyncAPI. We are not reinventing any wheel at all. And well, there is of course a small overlap between the inside and the outside communication. So now you have here all the information to build a backend application with this structure for JPA, for MongoDB, for producing domain events, for consuming events, exposing a REST API, doing some testing with a Spring Web Test Client, more testing with Karate DSL, and you have here a list of examples that right now it has just one example, that is this one that I'm working with you right now, that we are going to deconstruct and build back together. And as I said before, you have all the source code available in GitHub. So let's go back to our editor. I'm going to open for you the customer's blueprint. It has a config section with a base package. Persistence is going to be MongoDB. There are a set of plugins here that we can run, but we're going to hide them for now. Let's go to the domain model. We have a customer entity, which is the root of an aggregate, a domain-driven design aggregate that has some fields with some validations, some documentation, nested entities as well, this one addresses, which is an array of addresses. And we have here one service, customer service for the customer entity, which these different commands, and with publishing these domain events, customer event and customer address updated, that we are going to send using AsyncAPI to the Kafka broker, to these topics. And as you see here, each of these service commands, they describe the inside of your application. This is not a REST API, but comes with some REST annotations. These REST annotations serve two purposes. One is to document how the inside of your application is connected to the outside world. And another purpose is because we have these annotations here, and this is the blueprint that we are building during the discovery of the domain. We can use these annotations and these events to create, with these plugins, we are going to create an OpenAPI file. Okay, first of all, first thing I'm going to do is I'm going to delete the customers module source code. So now we have an empty customers module. We are going to rebuild it. Okay, so using this plugin, we are going to create an OpenAPI definition file. We are going to also create an AsyncAPI version 3 file. Again, you have all this information in ZenWave toolkit for OpenAPI, for AsyncAPI, and all the information is here. There is nothing magic. There is also some auto-completion you can get, but most of the documentation is enough to run this. So now we have a an empty module because, well, the idea is to use this domain-specific language to build a shared understanding. The owner of this language will be a technical expert in your organization, but bring to this as much people as possible, technical and not technical. This language is developer friendly, but if your technical people reads this domain specification to to business experts, they should understand perfectly what you are saying to them. Bring as much people as possible to this file, because once you have this file, I'm going to show you in a minute what you can get in terms of software development. So, okay, so now we have an empty module with some API first specifications for OpenAPI for creating customers, listing, updating, deleting, updating the customer address. We got also an AsyncAPI file for publishing customer events and customer address events. And if your organization is following API first principles, which is probably doing already, you already know that you can start a conversation right now with these API first files. You can start a conversation with your clients, with other technical people in other projects, in other departments, and you can create a lot of software artifacts. You can create mock servers, tests, clients, customer contracts, documentation. Well, this is the world of API first that I think we all know, we are all familiar with it. And I want to show you, because here in the POM file, we have a couple of plugins, the OpenAPI generator Maven plugin that is going to use this OpenAPI to generate some code for Spring MVC. We already know, I hope that we are familiar with this plugin. And we have also the ZenWave SDK Maven plugin that is going to do the same, but for AsyncAPI files. We can generate our models for our events, and we can also generate a complete implementation using Spring Cloud Streams. So as part of your build, here in the target folder, we got generated sources, OpenAPI. We should be all familiar with this, an interface for our API and some models. And we have also a ZenWave folder that generates mostly the same. It's the same idea. If you are familiar with OpenAPI API first, you will find this very straightforward. So we have here an interface for producing events and a complete implementation using Spring Cloud Streams and some models. So right now in the project, we have only the API first specifications, and we have some API first code that we can use to connect to the outside world. So now I'm going to use this blueprint to generate a complete backend application in this base package for persistent MongoDB. We are going to use Lombok, and we want to publish events to the to the outside world. So if I run this plugin, we get we get a number of files that, as soon as this refreshes. Okay, so this is the inside of a clean architecture or a hexagonal architecture. It comes with domain entities, inbound interfaces for our service, outbound repositories. It comes with an implementation with some mappers, and now I'm going to show you one of these implementations, because this code is very, very straightforward. We are not reinventing any wheel. We are just applying the domain knowledge that that you represented here in this blueprint. And for instance, this command, for instance, we get some input, we use a mapper, we use a repository, and we use an event producer to publish some domain events. Of course, the customer's microservice is a very simple one, but I believe that this looks very much like a lot of applications that we are building already on our enterprise. You see, you get one input, you find it by ID, the entity, you use one mapper, you use the repository to save it, and then you use an events producer to publish some events. Okay, so now what I'm going to restart the application to show you that we can still are able to create customers and to publish the events. Okay, the application is restarted. I'm going to create another customer. And okay, 404. All right, we have implemented here just the inside of our application. We still need to connect the inside of our application to the outside world. So here in this in the blueprint, we are going to use this other command to generate an OpenAPI controller using the information of this OpenAPI file mixed with the ZDL blueprint. So if I generate this, we get some files, and here, as soon as this refreshes, okay, we get some adapters with some mappers, and we have here a Spring MVC REST controller that implements our API, and nothing that you don't expect. A controller shouldn't have much business logic. We get a request body, we use one mapper, we call the service, and using a mapper, we send the response back to our client. So now I'm going to stop and restart the application. And hopefully this time, okay, so hopefully this time we can, let me bring these logs here as well. We can create a customer, we get the response, and the customer's module publish this customer details, this message to the customer events. So, okay, I know that the customer's module is a very simple one. It doesn't communicate with any other modules in this saga pattern, but at the same time, I believe that this implementation here is very similar to many of the microservices that we are building right now on our enterprise. So this would be a generic or supporting subdomain, but you can speed up your development very fast. The idea is to bring as many people, many experts to this file, because once you have described the solution that you want to implement, thanks to ZenWave, you can speed up your development as you see. So, but not every single module is this simple. So we can move on and go to the orders module, which is a little bit more complex, because the orders module is going to talk with the customer's module via REST API, and also is producing and listening for messages on the Kafka broker, a number of messages, a number of topics on the Kafka broker. So I'm going to show you, okay, this In the orders module, there is also a config file with the base package and the persistence. I'm going to hide these plugins for now, and we go to the domain model, and we have a customer order, which is the root of our domain aggregate, and it has some fields. It has some nested entities, the customer details, the restaurant details, the order items, which is an array of items. It has an enumeration of order status, and an order can go by all these status. And we have here a service, order service for our customer order aggregate with some commands, also annotated for REST APIs, but we have here this command which is going to listen using AsyncAPI to the restaurants API at this channel for updating the kitchen status, and this other command that is going to listen using the AsyncAPI to the delivery API at this command, at this channel, the update delivery status. And they are also publishing order event, and order status updated, which are these messages that are going to be published to AsyncAPI at this channel and at this topic. So now we can go back to our plugins. We can generate an OpenAPI file. We could generate an AsyncAPI file. Once again, there is no magic here. All the information and all the available options you have here in the SDK page. And now we are going to build a backend application, persistence MongoDB. We are going to use Lombok, and we want to publish events to the outside world, and we are going to use force to overwrite all the existing files. So with this, we are generating the inside of our backend application. And now what I want to do is I want to use Git, the source control, to show you the difference between the code that we got before working, the custom code for our application, the finished code, and compare it with the code that we get at first round with ZenWave plugins. So now I'm going to use source control to show you. Here we have some difference. For instance, in the mappers, there are some custom code, customizations in our implementation in the mappers. In the events mapper, there are some customizations. There are also some custom code on the order service mapper. And first thing I'm going to do, I'm going to roll back these changes so we get this implementation back very quickly. So now I have the finish option, and I could do the same with the service, with the order service, but I prefer to copy these changes one by one to show you that the difference between the baseline that we get from ZenWave and the finished code, well, it's not that far. And obviously, there is always work and there are always details that you need to implement. Okay, so let's look at these changes. If you remember, the orders module talks with these Kafka channels, but also talks with the customers module. There is no line here, but it also talks with the restaurant module through a REST API to get some customer details and the address of the restaurant. And so these two are OpenAPI generated REST clients. So the first thing, I'm going to bring this back, and I'm going to bring also the imports. So this we can compile it. And now I'm going to copy one by one. Let's all the commands to show you that the difference between the baseline and the finish line is not that far away. So for a create customer order, we have something that we can expect. We have one input, we use one mapper, a repository, and we produce some events using an event producer. So I'm going to copy the actual finished code here to show you that it's actually not very far away. First, we need to connect to the REST APIs with these REST clients, and then there are some customizations about the initial status, about the time of this order, but mostly the code is mostly the same. So for update order, I'm going to copy also this code. Okay, there are some customizations here about we need to get the previous status. So to know if we need to send an update of the status, we also, well, that's it. Mostly that's it. We need to keep track of the previous status. Then we are using a repository, using a mapper, the repository to save it, and the event producer. And this one, which is for listening for kitchen status updates, I'm going to, okay, the original code, as you may expect, you get one message, we use our repository to find the actual entity, we use one mapper to update it, and then we publish some events. And the finished code, not very far from this. We need to keep track of this. If this status change is rejected or cancelled, we need to cancel the order, and then it's mostly the same. And for the update delivery status, which is this one, is similar. The delivery and the restaurants work mostly the same in this case. So again, we need to keep track of the previous state, and well, if it's reject or cancel, we need to cancel the order. Everything else is the same. And regarding canceling orders, we will need, I'm pasting here this code again, tracking the previous state. If the order was already cancelled, we don't need to do anything at all. And then if we are canceling, we set the status to cancel, and we publish another event for the rest of the services to receive that message as part of our event-driven communication conversation. So now, what I want to do is to stop the application and start it again to show you that, let me bring this logger here, to show you that we can still create orders and we can still advance the orders and cancel the orders. So create here it is, create order for this customer at this restaurant with these order items. So I'm going to hit send. And again, we got a received response, the order was received, and now a lot of interesting things happen behind the scenes, event-driven architecture. The orders publish, the order details, receive status, and the restaurant accept, the delivery accepts. So now the order is confirmed and the restaurant is in progress. And we can copy this kitchen order to drive this order a little bit further. So we are going to set this order to ready, and here it is. So now the delivery is in progress, and we could cancel this order anytime with this customer order ID. we could cancel regardless of the implications in real life. I mean, this is a simplification, but I believe showcase the complexity of an event-driven application. So let me show you about this implementation, because once we generate the code, well, first, again, the idea is to model this using DDD and event storming techniques, bring as much possible, as much people possible to this file, because you will get very early feedback and it will surprise you. If you bring non-technical people and you narrate the contents of this file, it will surprise you, the early feedback that you will get. Because as soon as you have this blueprint, you can generate a lot of software artifacts to build your application fast and based on your shared understanding. So I want to show you that this implementation is very, very straightforward. It doesn't have any strange dependencies, just Spring Boot, Spring Data, Spring Cloud streams, MapStruct, and Lombok. And it's very, very simple, very straightforward, very easy to understand, very easy to maintain. Where all the logic is exposed on services, and the entities are just holding the data, right? This is a design pattern that sometimes is referred as lightweight entities or data-centric entities. Other times it's also referred as the anemic domain model. But I believe that this architecture is good enough for most of the backend applications that we are building in our enterprise. But sometimes you need to deal with a bit more complex business process, or your service need to handle more than one aggregate, or you need to keep track of different status in your aggregate. So thanks to ZenWave, we can implement domain-rich aggregates. So let's go to ZenWave web page. Here we have a section modeling aggregates. Just a small parenthesis. Oops. Just a small parenthesis. From a domain-driven design perspective, an aggregate is a cluster of entities and values that work together as a single unit, a transactional boundary and a single unit, and has a root entity and some data inside. We can model lightweight, data-centric, rich domain aggregates, or even event-sourced aggregates. And as it says here, if your application logic is simple, keep it simple. Don't overcomplicate things. This is sometimes called an anemic domain model, but I believe this is okay for most applications. So if you're not sure if you need it, you probably don't need it. And even if you think you need it, think twice, because source code is not an asset. Source code is a liability, something that you need to understand, and you will need to maintain it on time. So less is better. So keep this in mind, and if you need it, in case you are building complex business logic, or you have multiple aggregates, or you need to encapsulate different state transitions, or you are dealing with a core subdomain where you are trying to create a differentiating value proposition, then you can create rich domain aggregates. This is the format. You create an aggregate object for an aggregate entity. We don't need to annotate with the aggregate right now, and there are commands, and you can publish events. And then the domain service, it references reference the aggregate instead of the entity. And you can also listen to AsyncAPI commands, publish events, listen to REST APIs, and the implementation, in this case, of the service itself, it looks a bit simpler because all the logic, all the complexity, you are moving it to the aggregate. And this requires much more code, is a little bit more complex. There will be a learning curve for your team. So keep in mind that all this source code, if you create it, you will need to maintain it. So, okay, you get an aggregate with a root entity, with a list of events, and the implementation of each command doesn't depend on repositories or external dependencies, but it adds some complexity. And because we have 2 modules to go, what I'm going to show you is, because the restaurants module and the delivery module were implemented in different ways. The restaurant module was implemented as lightweight entities, and the delivery module was implemented with an aggregate object. So I want to show you the difference in the code. The restaurants implementation, restaurants order, okay, and okay, let's bring up also the delivery. Okay, so this is the difference in the implementation. As you can see, create a new delivery looks simpler with rich aggregates. Well, this is a bit misleading because there is also here a method for persisting and sending events that may grow, but the command itself looks simpler. But I believe this is simple enough. I mean, you have one input, you have one mapper, you have a repository, and you publish a new event to the outside world. So this is also very simple, and this has some complexity on its own. If we go inside, for instance, this is how we create a delivery. For instance, we need to set the entity ID, the aggregate ID, on the client side. We cannot delegate this to the database. Why? Because if we are publishing domain events here inside the aggregate, we need to have the ID of this entity. This kind of complexity, you will find out this file, well, is source code that you need to maintain, need to create more files, more code. But if you need it, if your business logic is complex, you have this option for modeling, following DDD practices, DDD best practices. And sometimes this is considered to be easier to test because, as you see here, there are no repositories, there are not REST clients. It's just normal Java code, flat Java code. But I believe that this is also very easy to test. We have some repositories and we have an event producer, but because this follows a clean architecture where all the communication to the outside world goes through interfaces, we can provide in-memory representations, in-memory implementations of these interfaces. So I want to show you one test to show you that you can, here, the restaurant implementation, service implementation. I want to show you this test. As we see here, this is a service, a restaurant orders service test. And I want to show you how easy it is to implement a test for this simple implementation. Okay, we create some input data, initial data, we call our service, and then we can do assertions on the repository, and we can do assertions on the events producer. And ZenWave already generates for you an in-memory implementation of these interfaces. Here at the top we have a services in-memory config that, as we can see here, we got an event producer in-memory context. So that implements the event producer and saves all the messages just in an array list inside a map. Very simple. We can run this without containers, without Mockito, without anything. And we also have an implementation of all the repositories. So kitchen order repository in memory, as we can see here, implements the Spring Data Mongo repository, and it keeps all your data inside a map of entities. And you don't need to implement this by hand. You can just inherit this, and you can add any custom methods, but this is already generated for you. So let me run this test. Create kitchen order test to show you that this is a unit test. This doesn't use containers, it doesn't use Mockito, it doesn't require you to have a slow test or complicated test. You see, milliseconds. This runs in milliseconds. We can also place a breakpoint here, and we can debug this. We can capture the events messages that we are sending to the outside world, and you could do any assertions. Here are the headers. This is the payload for this order, which is accepted. And okay, so it's this simple. You don't need to overcomplicate things. But once again, I say, if you need it, you can use it, but use it with care. So now we have some questions in the chat. No, there are no questions. Well, if you want to ask me any question about this tool and techniques, I will be happy to get them now. And otherwise, I just want to finish explaining that that this doesn't generate any code specific for ZenWave. It creates code for you with very basic dependencies, and you can also customize this code. You have here in GitHub. This is open source, by the way, and you have here a way to fork a custom plugin, to fork a standard plugin and create your own custom implementations, because sometimes in your organization, well, you maybe are not using exactly Spring Data, or because you have a different starter or a different library or some custom annotations that you want to use, so you can create your own custom plugins. And also, I believe, regarding customization, I believe that microservices don't need different Maven modules, but there is a customization already created that can generate these microservices with Maven modules. It's not documented in the website. The reason for that is because there are 1,000 ways, infinite ways of creating mapping modules. So I don't want to publish something I don't believe is the right way to do it, and at the same time choosing the names of those mapping modules. But if you are interested, if you are the ones that believe that sometimes a microservice needs mapping modules, you can ask in GitHub. Just open an issue and I can assist you creating these customizations. So just to finish, let's back up and go back of what we see. The main idea is to use domain-driven design and event storming to understand to use language to create a foundation that can accommodate change, to understand the problem space always before building a solution. First, understand what is your client's problem and recognize and understand that problem, and then, only then, design and discover a solution, because today, with the changing environment, a solution needs to be discovered and iterated. And with event storming, you can explore the problem space, you can design your processes, or you can design your software. Thanks to ZenWave, you can convert these findings into a domain model that can be converted to code very quickly, and it generates code for you very, very simple, and it retains the language of your business. So this can work as an ubiquitous language format. And event-driven architectures, well, because it makes sense, because that's how we conduct business in real life. ZenWave can compress the feedback loop between expert knowledge and working software with tests, because the main reason that software projects fail is because, first, we don't have a clear understanding of what we want to build. The humans, we are not good at knowing what we want until we see it. So thanks to this iteration, you can formulate different hypotheses and validate them without getting married to any solution, to your first solution that may not be the right one yet. So you don't need to live with technical debt. You can cut your losses and use domain-driven design techniques to understand your problem, validate an hypothesis, and then move forward. And this is the application that we used. As I said before, the source code is already published you can find it in GitHub. And the next week, we are thrilled. We are going to have here from Mendez. We are going to talk about API first with AsyncAPI and API management. If anyone doesn't know who Fran Mendez is, he is the founder of AsyncAPI initiative, which is the de facto standard for describing event-driven APIs. And we are going to use this same application for building the same application to explain API first concepts and API management, because version 3 of AsyncAPI specifications brings a lot of flexibility to the table, and we are going to try to explore different options for your company, for your organization, so you can choose knowing and understanding how it works. So I hope you like it, and see you next week. Thank you very much, and happy coding.